All right, so today we're going to extend on what we did yesterday. Yesterday we we had a system of equations, we found its augmented matrix, and then we put that matrix in row echelon form. And today we're going to continue the process and use that row echelon form to solve the system. So for example, the first system in our video yesterday was a little 2 equations and 2 unknowns right here. The augmented matrix, you just take all the coefficients, the coefficient on x, the coefficient on y. So these are my x coefficients, these are my y coefficients. This is sort of my equals, and these are my answers over here. And then I can use my process of row echelon form to put it into this down here, row echelon being 1s on the diagonals, and anything below a 1 above at its first entry, everything below will be 0s. And so this system down here, the row echelon, is equivalent to the augmented matrix. It will have the same solutions. So today we're going to look at how do we actually solve this. And remember, this system right here, again, if this is my x coefficient, this is my y coefficient, this is my equals, here's my answer. This system can be represented by x plus 2y equals 1 and 0x plus y equals -1. And what that gives me down here is the first part of my solution is that y is -1. And having this 1 here will generally give me that 1 answer. Then I'm going to use my first equation now. I'm going to use some substitution. And I'm going to say x plus 2 times y equals 1. And now I solve that. So I have, this becomes x minus 2 is 1, or x is 3. And I have the solution of 3, -1, if you want to write it like a point. So that's sort of the process. We can expand it to using 3 variables, 3 unknowns. So first we're going to take this. So this is number 6 from your mastery yesterday. And this system, I gave you a augmented matrix, and then it represents this system, x minus y equals 6, because we'd have 0z, and I'd have 2x, now I have no y's, but 3z equals 16, and my final equation is represented 0x's. I have 2 y's, 1's plus 1z, it's going to equal 4. Again, we're using this as my x coefficient, my y coefficient, my z coefficient. We showed yesterday how to turn, hopefully in your mastery, you turned this augmented matrix into row echelon form. It may not look exactly like mine, depending on what steps you took, but it should be equivalent to this in some way, and the solutions should be the same. So I'm going to show for my row echelon. If you have a different row echelon, you could try that. But again, as we're thinking, this is my x coefficient, y coefficient, z coefficient. So my very bottom equation says that 1z equals 0. So now I have a number for z. The next equation that I get out of here says y minus 3/2 z, but we just said z is 0, is going to equal 2. And 3/2 times 0 is 0, so we get the equation y equals 2. And now I'm going to substitute my y and my z up into my very first equation, which says x minus y, well that was 2, and then plus 0z, and z was 0 as well, is 6. So this becomes x minus 2 is 6, or x equals 8. And so our solution for this system is 8, 2, 0. Now it's worth it to check whether that actually works. You can go back up and plug these numbers into your original equation right up here. Indeed, 8 minus 2 is 6. If you do your here, we'd have 2 times 8 is 16, minus 3 times 0 is 16, and down here 2 times 2 plus z, which is 0, does indeed equal 4. So it works. It's a good idea to check. As we're doing our solving from row echelon, we really have 3 options for what our solutions will be. In some cases, there's no solution. There can be one solution, or there can be infinitely many solutions. And how that would work is if I have a row echelon matrix like this, and I think about writing my equation, again, if this is my x coefficient, my y coefficient, and my z coefficient, all those zeros times whatever numbers I might get for x, y, or z end up giving me 0 equals 1. And that is impossible. And what we say in terms of the solution is we say the system is inconsistent. In our next one, this is a system like we have one solution like the one we just did. I would have a z equals 8 from right here because this represents my z coefficients. And then I can use that z I found and this equation represented by that row, which says that y plus 3z, well in this case z is 8, is 4. So y plus 24 is 4 and y is negative 20. And then I can use those two numbers I now have in my very first equation, which says x plus 2 times y. Well, we just said y is negative 20, plus 5 times z, but z is 8, equals 7. And this becomes x minus 40 plus 40. And these cancel out, and I end up with my solution of x is 7. So there's one solution, and only one. 7, negative 20, and 8. Now the final option is infinitely many solutions. And that will come because what I have over here, if you have your 0x, 0y, 0z is 0, all those turn into 0 is 0. Now that is possible. And so we say this system is what we call dependent. We are not going to really investigate or do much with dependent series. You should just recognize that it is possible to have infinitely many solutions for a system of 3 equations, or for any system, actually. Okay, let's try one more. Now, if you feel like you are solid on putting things in row echelon, and now you feel like you have a pretty good idea of how to go from row echelon form to your solutions, this might be a time to stop the video and try your mastery. I'm going to try one more here. So if you feel like you still want a little more help, you can try along. You could try to do this one yourself and then run the video and see how it goes. So my first step in solving the system using row echelon is putting it in augmented form. And so again, I'm going to write my coefficients, and I write 1, negative 3, 2, and then 12 for my first row. And my second row is from my second equation, which says 2, and a negative 5, and a 5, and a 14. And my third row is 1, negative 2, 3, and 20. So there's my augmented form. And now I'm going to use my row echelon process, which looks something like this. I always want to make my first row start with a 1. Now, if there isn't a 1 there, I can, or if I have another row that has a 1, I can move it up. And if not, I would multiply my first row by a constant so that I would get a 1, and it would be the reciprocal of that first number. And it's also nice to look for ones that have perfect multiples, that are perfect multiples of the first. But I have a 1 in my first, so that is good to go. So my next step is to replace row 2 and row 3 with what I get when I add multiples of row 1. So for row 2, I'm going to replace it with negative 2 times row 1, and then I'm going to add that to row 2, and that should make sense. This is very similar to what we're doing with elimination, because if I multiply row 1 by negative 2, I'm going to get negative 2, 6, negative 4, and then negative 24. And when I add that to my current row 2 of 2, negative 5, 5, 14, I get 0, 1, 1, negative 10. That is what I'm going to put as my new row 2. So my row 1 is going to stay the same, 1 minus 3, 2, and 12. I'm going to replace the old row 2 with my new row 2, which has a 0 as the first term, which is awesome. And then I need my new row 3. Now row 3 I can get by basically subtracting row 1, or adding the opposite of row 1 to row 3. And I could write that over to the side. I like to do that so I can see my work and where I may have made a mistake, because there are many places where you can make a mistake in this process. But I think this one I can do in my head. I just take 1 minus 1, and that's going to be my 0. And then negative 2 minus negative 3 is the same as negative 2 plus 3. And I get 1. And then I do 3 minus 2 right here, minus this. And that gives me a 1. And finally, 20 minus 12 gives me an 8. So I'm closer to my row echelon. I have my 1 with all zeros underneath it. And then I have another 1 starting right here, which is good. And then I want zeros underneath it. So my next job is to make a 0 here. And to do that, I'm going to replace row 3 this time with the opposite of row 2. And again, this is one I think I can do in my head, because really you're just subtracting row 2 from row 3. So my first row is the same. Now my second row will stay the same. My third row I want to change. So I'm going to take 0 minus 0, and that's 0. 1 minus 1, and that's 0. 1 minus 1 again. It's going to be 0. And 8 minus 10 minus negative 10 is going to be 8 plus 10. There's my 18. Now really, to be row echelon, I need this, the first term in that row, to be a 1. And so I would do one last step of row 3 is going to be 1/18 of the current row 3. And I can just throw that in here and do it, because all the other zeros, when you divide by 18, will give me 0. This gives me a 1. And now I look at this, and this reminds me of my no solution, because when I use zeros as my coefficients for both x, y, and z, I get 0 equals 1. That is impossible. And that is an inconsistent system. So hopefully now you have enough to attempt mastery. If not, I will be doing a video of one more problem from start to finish that has solutions, so we can do the whole, write the augmented matrix, put it in row echelon form, use your row echelon to solve with what's called back substitution.